In this question, it's mentioned that a person can complete a job in 120 days. He works alone on day one. Now, on day two, he's joined by another person who has the same efficiency. So, the second person can also finish the same work in 120 days. Again, the next person on day three that joins also has an equal efficiency. So, every day, a new person is joining, but the new person has the same efficiency as every other person in the group, right? So all of the people have equal efficiency. So what you can do is you can just consider that efficiency of each person is 1 unit. So if that is true, we know that each of the persons, so the first person, for example, can complete the work in 120 days. So assuming that efficiency of each person is 1 unit, so the total work should be equal to 120, because in 120 days with an efficiency of 1, these people will complete 120 units of work, right? So now we know that the total work is 120 if the efficiency is 1. So now we can relate these. So how are they working actually? In the first day, one person is working, so that will complete 1 unit of work. In the next day, two people are working, so that will complete 2 units of work in the second day. So this is the second day of work. In the third day, three people are working, so that will complete 3 units. So this will go on. After on the nth day, let's say, so that is what we are looking for, how many days are required to complete the job. So on the nth day, there will be n people working, so that will complete n units of work on that particular day, right? So the total work done by this much time is this much, and we need to find we need to complete the total work here, right? So that is the work we are trying to finish off, so 120 units. Now in these cases, it's not mandatory always that this 1 to n summation will hit on 120 exactly. So you might get a fractional work done on the next day. So what you can do is just assume that this is less than equal to 120, because we are looking for basically the day on which it is either completed or the full day is done, and then after that the next day a fractional work is done. So that is why the point of less than equal to, you can even consider greater than, but then you have to backtrack again. So you can just consider this. I hope everybody is aware of this formula, simple average idea used by Gauss. So this is n into n plus 1 by 2 less than equal to 120. Let me write this a bit proper. Yeah. So in this case, I hope you can see that we have something like this, right? And we're trying to fulfill 240 if possible. So the best way to resolve something like this is not going to quadratic, but just think about a perfect square, because n has to be an integer, right? This is what we are looking at, the day on which, up to which point there are whole number of days getting consumed, something like that. So if we assume that this is an integer, so n square has to be a perfect square, right? So think about a perfect square which is just below 240. I hope you're good with perfect square. So you'll straight away notice that 15 square is 225. And simply if n is 15, so this is also 15. Now you will find that this is exactly equal to 240. So n equal to 15 works, right? So n equal to 15 works, and that is the requirement on which day, how many days are required to complete the job, or in other words, on which day the work is completed. So this is n equal to 15. So the answer is 15 days in this case. So I hope that was understood. This is a very simple problem. Ideally, if you understand these kind of ideas, you assume the efficiency, total work. So these kind of things will take hardly any time. And if you have a practice of these type of questions, so you will automatically understand this relationship. And then coming to here and solving this with this idea, it becomes very fast. So I would say roughly a minute or something to solve this question, maximum a minute to solve this question. So if you don't have a practice, you might take 2 minutes, but I'm talking about ideal time here. So this is the answer for this question, and I hope that was understood. Thank you.